Hi, this short video has been produced to help with questions that may appear in the Scottish Qualification Authorities exam for the Higher Physics course. Once again, we're still on our dynamic universe and we're looking at one of my favourite subjects, gravitation. So here we have a question. Gravitation lends itself to equations. A highly energetic dolphin, Maisie, has jumped very high into the air over the ocean. On her way back down to safety, she has a terminal velocity v sub t, such that v sub t equals the square root of 2mg over rho cap A cap C sub d, where m is Maisie's mass in kilograms, g is the gravitational field strength in newtons per kilogram acting on Maisie, cap C sub d is Maisie's drag coefficient, rho is the density of air in kilograms per meter cubed, and A is Maisie's area in meters squared. Now Maisie, who has an area of 0.9 meters squared, free falls. She has a drag coefficient of 1 and she reaches a terminal velocity of 30 meters per second. If the gravitational field strength is 9.8 newtons per kilogram and the density of air is 1.21 kilograms per meter cubed, what is Maisie's weight to the nearest whole number? And then we have a selection of choices. So what's our approach going to be? Well, we know we need to read the question closely and pick out the things we're being asked about. So here we need to kind of ignore the whole story about Maisie and not get lost in it. We just need to recognize we have an equation, we have some numbers that align to the factors in that equation, and we just need to calculate an answer. So we need to look at the options and see if there's anything obvious we can ignore. Well, we're being asked for Maisie's weight to the whole number. And what do we know about the units of weight? Well, we know mass and weight are different things. We know that mass is often measured in kilograms. Weight is more likely to be measured in newtons. And therefore we can ignore options B and C because they're presented in kilograms, which would be a mass, not a weight. We need to recall the part of the course we're talking about here so we can ignore other parts of the course. Always read the question again, even if it's lengthy. It just makes sure you're focused on the right thing and avoid overcomplicating. If you're getting lost in the story, ignore the story and just go for replacement of the numbers into an equation. So what do we know from the teachings? Well, the question is focused on the way an object falls. And obviously there's some kind of resistance acting on it, in this case air on our Maisie. And you're given an equation and we know that we have some numbers that fit the equation. You have to figure out firstly which number you don't have, obviously the one you're usually being asked about, and rearrange the equation so you can find that value. In this case we have all the details except the mass. So let's rearrange the equation for mass. So we need to take away that square root by squaring the velocity. That looks a bit nicer. We then need to cross multiply so that we have the velocity squared multiplied by the term on the bottom, rho cap A cap C sub d, which is equal to 2mg. And then we can pull across the 2g so that we can find the mass. Now, obviously in this question we're careful because we know we're not being asked for the mass, we're being asked about the weight. But we know that weight is equal to m times g. But we had this m times g term earlier on in the equation. So instead of pulling across 2g, we could have saved some time and obviously just pulled across 2, leaving the mg there, which would have given us Maisie's weight. So there we go, we have the correct formula and we need to plug in the numbers. So let's do that. We'll take the equation that where we pull across 2g, plug in all our numbers for the mass, and we get 50 kilograms. Obviously, if we'd stopped there, we might have marked answer B as correct, but of course that's the mass, not the weight, and so we need to multiply through by G for the weight, and we get 490 newtons, which leads us to answer A being correct. So, things to note. Deciding which variable we need to calculate is key. So you might want to mark that on the paper that we're looking for weight and what the equation for weight is, mg, which is available in the sheets in the exam paper. Need to be careful when rearranging. That's where it can often go wrong. Things like the squaring of velocity can often get lost, or the way you cross multiply may be incorrect, so be careful there. We need to not to forget to use that square number and not to forget to use whole numbers in the equation. And make sure that the answer is the actual dimension you've been asked for. There are other problems to try available here, and the answers, as always, are on the Hi page, hi.page/physics/FYSX. Thank you again for watching, and look forward to seeing you in another question.